Transition. Okay. Yeah, we're recording. Okay, so just bear with me. We'll run through the first little bit here, which you're obviously already aware of, but we'll skim through it quickly. So what is HVAC? HVAC is a term commonly used in our industry. It just means heating, ventilation, air conditioning. Air conditioning is a process of removing radiating heat to a building to provide comfort for occupants. Ventilation is removal of unwanted odours, dust or fumes, etc., or provision of outside air. Ventilation is a very big subject, but they're the main things that we deal with at this stage. You will get involved in more complex projects as we go along, but at the moment, that's the basic things that we do. What heat exchange occurs in buildings? Two basic things. There's a cooling cycle and a heating cycle. This is all very straightforward. In the cooling cycle, heat enters the space from outside and inside due to external sources are solar radiation through windows, glass doors, etc., transmission through walls and roofs, warm outside air intake. We have to bring outside air in for ventilation, but it brings heat with it as well, and moisture. And there's infiltration, which is leakage. All buildings have a bit of leakage. Buildings are better these days, new buildings, but they all leak a bit, so that allows heat in as well. Internal heat sources include lights and people, in equipment in the space, computers and printers and those sorts of things, and transmission through internal walls and partitions. So if you have spaces inside the building that are hotter than others, you'll get some heat transfer through the partitions. The heating cycle, heat is leaving the building because it's colder outside than you want it to be inside. And that causes the temperature to fall. So the sources of heat loss in reverse to the heat gains. You lose heat through walls, the roof, floor, windows by virtue of the temperature difference. You bring in outside air, which is cold, which needs to be warmed up. And again, you have infiltration, leakage of air into the building. Ventilation is required to provide a healthy environment by providing fresh air from outside and removing stale air and odour from inside. So the basic things that we do every day of the week are outside air intake, which is a requirement of AS 1668 Part 2, and let's say toilet exhaust. Most buildings have that, where we have to take that stale air from the toilets and discharge it outside. AS 1668 Part 2, I'm sure you're familiar with that duo. I don't know, Jelen, whether you've had much to do with that yet? No, not yet. Yes. Anyway, that's probably the most important standard that you need to be familiar with at this point. Why is HVAC needed? It's necessary to provide a healthy and comfortable environment for people to work in. It improves occupant productivity and well-being. And there are many applications. Obviously, you're doing a lot of commercial work and residential at the moment, but equipment room, environmental control, data centres, laboratories, hospitals, pharmaceutical manufacturing, food processing. Why is it important? Without HVAC, many buildings would be unsuitable for occupation and many processes would be impossible to control. So apart from the comfort aspect of residential or commercial, many air conditioning systems are required to control processes. And this is where it becomes very interesting. And you'll do these projects as we go along. Scientific, industrial, pharmaceutical, food processing, etc. University laboratories, really interesting work. Hospitals, terrific stuff. So you'll get involved in those as we move along. Now, what are the rules? National Construction Code, or NCC, sometimes called the BCA, which means Building Code of Australia. That's what we all used to call it, but now it's called the NCC. That sets out the requirements for building and relevant Australian standards to be applied. In the NCC, there is a list of Australian standards, which are called gazetted standards. if they're listed in the NCC, you must comply with those standards as well. If they're not listed, then they're based, and the standards exist, then they're a recommended document, but they're not mandatory. Okay, but you'll find always that AS 1668, Part 1 and 2, will be referenced in the BCA. So you must comply with those. So you'll see here I've got references to those standards. So the idea of this program was that we would bring those standards up and go through them, but you're familiar with them. You'll be working with them every day. So they are very important. With the NCC, I've mentioned further down in the document, but I'll mention it now. Section J is one that you need to read through. I think I mentioned this the other day to you. Get familiar with that, because there's a lot of things in there that you need to apply almost every day that you work. How do we get involved in projects? Projects come to us in various ways. We might get a set of mechanical services drawings and specification which have been prepared by a consultant. This is probably the more common way. And from that, the contractor, who is our client, needs to work out a price to provide that system. So that's basically just the job has been designed. Our job is to work for our client who's priced the job and work out the engineering details and so on. We may get a set of architectural drawings and perhaps a design brief from which we can produce a preliminary design to enable a tender price to be calculated. So Philip and Ivan do this quite a bit. They'll be given some documents. They'll do a quick design for the contractors to work out a price, and then it becomes what's called a design and construct tender. We design and construct, where our client, the contractor, does the construction. We might get a client brief setting out their requirements for a new or existing building, from which we can produce a preliminary design. So this might be a simple thing like a letter from a developer who says, I'm going to build a building. It's going to be so many square metres. I'm going to use it as an office, and I want 24 degrees in the space. Please work out something for me. I mean, it sounds silly, but sometimes you get those requests. Any questions so far? Sorry if I'm going a bit fast, but I think all that stuff you're familiar with anyway. Who are the parties involved? Now, this is the thing that Phil was really wanting to give you a bit of context as to how many people are involved in these projects, because there's lots of them. And where do we fit in to the project? So just going down this list, there is a client at the top of the tree. Basically the organisation or the person providing the funding for the project. Now, this might be the government, it might be the Defence Force, or it might be just a person who's, or a small organisation that's got some money that they want to invest and want to build a building. So the client could be a number of people. The client may be the developer. The developer is normally the client's representative, but could be the client. In other words, could be the person who's putting up the funding for the project. Next, we've got the building or construction manager or main contractor. Commonly, we would call this group the builder. And the builder engages, well, in most projects, engages the architect and all other consultants and the subcontractors. Now, our role in this process is we generally work for the subcontractors, the mechanical subcontractor, mechanical services subcontractor. So they're our client, and their client is the builder. And the builder is the organisation who builds or manages the construction of a project. And as I said there, they also normally engage and manage the various consultants and subcontractors, including the mechanical services subcontractor, who is our client. there's an architect who designs the building. In the current situation, they're normally engaged. Well, they're involved before the builder. They would, before the builder comes in, the architect would design the building and would be engaged by the developer or client. Quantity surveyors, they're the ones who do the estimating of the building cost so that they can keep that. The client's going to have a budget, so the quantity surveyor tries to keep the project on track with the budget. The structural engineer designs the structure, works very closely with the architect to develop a building that is going to stand up. Civil engineer, they usually design the stormwater, sewer, roadworks, parking areas, things like that. There's a fire engineer. Now, you would have probably Dua in particular. Can you still hear me okay?
Yeah.
My screen just changed a bit, but yeah, okay. The fire engineer carries out an analysis of the building fire safety and may request specific requirements or amendments to the NCC or Australian standards. John, you may not have looked at a fire engineering report yet, but Dua, I think you probably have. Would that be right?
Yeah.
Just about every project we work on now has a fire engineering report. The fire engineer, this is a relatively new thing. Well, let's say it's been happening now for more than 20 years, but when I say relatively new, when I started work, this didn't happen. But now it does, and we have to comply with what the fire engineer wants. And usually, well, not usually, but sometimes, and
You're frozen again. Slow connection this morning. Let me send him a message so he knows.
Yeah.
you're back.
Yeah, you're back.
Did I lose you there for a second? Oh, yeah, okay.
Yeah, we lost you.
Okay, so-
The last thing we heard was that complying with the fire report is relatively new. 20 years old, but it's new to you.
I'm old, see. Yeah, okay. Well, it is one of those things now that it's just part of the process and we have to comply. And you need to be aware that most projects will have a fire engineering report. You should be looking for it and read it and understand the requirements and comply with those. There's a building certifier or surveyor. These days, they're usually independent companies. They used to be part of the local council, but basically they provide the building permit and they will have requirements as well. When they issue a building permit, they will have some requirements. Again, we need to read those and make sure we comply. The mechanical engineer or consulting engineer is the firm that produces the designs that we normally work to. You know, when you get a set of design documents, there's a mechanical consultant who's produced those. Likewise, with electrical engineer is the lighting and power designer, hydraulics engineer or plumbing systems. There's a fire protection engineer and designer. Now, they're the engineers who design the fire protection systems like sprinklers, hydrants, hose reels, etc. But they're not the fire engineer. The fire engineer is the one who's modelling the building fire safety and producing alternative designs. Do you know that distinction? Are you clear with the difference there? They're two separate companies altogether.
Yeah, but Now, obviously, it's a bit different because the fire engineer is the architect. He's responsible for studying what needs to be done in the building to protect it from fire, including fire compartmentation, submitting the report. Now, the fire protection engineer is the mechanical engineer. It's part of what we did as mechanical engineers. Although I'm always against the word protection, we don't protect, we just fight. It's fire protection services because, I mean, fighting, because once the fire starts, you fight it with your sprinklers, with your hydrants, with whatever. You're fighting fire, not protecting. So anyway,
Oh, true,
bit
yes. Well,
different,
that's true, yes,
different
exactly, yeah.
terms, different
Yeah,
roles,
different,
but it's good now to
different
know that
terminology,
the
yes.
fire engineer is someone who designs he doesn't design the system that consists of pipes and pumps. He wants you to comply with whatever requirements are there. Right? Am I
Correct.
right?
Yeah,
Yeah. All right.
yes. Yeah, that's right. And then there's lifts, elevators, vertical transportation, generally called. And then all the subcontractors who carry out the work, of which we are part. As I said before, we are working for the mechanical subcontractor. Generally speaking, sometimes we work directly for a client. I know that Philip and Ivan sometimes have a client who come to them directly and ask them to prepare a design. So that happens as well. So going back to the builder, all of those companies that are listed below the builder are normally managed by the builder in a project. So the architect and so on might start before the builder comes along. But then as soon as the builder is engaged, all these consultants are novated to the builder. So they work for him or he or she, but it's a building company, obviously. And that's how the projects are normally run these days. So in the food chain, if you like, we are down the bottom. Okay, and we work for a mechanical subcontract, who then works for the builder. So in the chain of communication, we would normally talk to the subcontractor if we have a query or request for information. We speak to our client, who is the mechanical subcontractor, and then he would have to ask the builder, and then the builder has to ask whoever he needs to ask, which would be the developer or client, and then feed it back to us. So that's where we are in the food chain. Any questions?
Yeah. Let me explain to you quickly uh, the connection between the ventilation HVAC design, smoke control as well, smoke exhaust and control, and the fire engineer. They're interconnected overseas, and they both should comply with whatever government and local standards are there. Is there any kind of interconnection here in Australia? I mean, it's not part of what we do, but we might want to do it someday. It's what the mechanical
Yes.
engineer does. If he designs smoke control system and smoke exhaust system, would he want to, is he required to comply with fire systems at a stage? Is there any kind of authority that they both refer to?
So what happens in the design team, which is, let's say, from the architect down through the consulting engineers, including the fire engineer, they all work together producing a design. And the mechanical consultant, well, they work in teams. They go to meetings and have their discussions and they communicate with each other. This is long before the subcontractors get involved, and even before the builder gets involved, probably. And mechanical engineer would produce a design basically in accordance with the NCC and Australian standards, as do all the other consultants. But then the fire engineer may look at alternative ways of doing things as part of that design team. So he might say, well, for this particular building, And there's a building that I've been looking at with Philip, which has got an atrium, which is an open well in the building. And there's been discussion about the stair pressurisation and the smoke exhaust, which becomes quite complicated. So the fire engineer has had a look at it, and he said, well, the design of the building doesn't really comply with the NCC. However, if we do A, B, and C, then the building is still safe to be occupied. So it may not comply with the NCC, but it's still safe. So that's where the variations occur, and can make it a little bit, well, it makes it more complicated for us because we're not following the set rules. So in that case, the fire engineer has the authority to do that as long as the building surveyor or building certifier agrees with it and provides a permit. So it's in the consulting group, they work through all those options. And actually the fire brigade could be involved as well, because they may be invited to meetings where the fire engineer says, this is what we propose to do with this building. It may not comply with the NCC, but we've done the modelling and we believe it's safe, and it gives you safe access to fight the fire. And then the fire brigade, who are usually pretty well educated in these things, they can either agree or not. They may disagree and they might have to change it. But generally, I think they would probably say, yes, okay, we can see what you've done and we agree. And that becomes the design for the building. So all that's happening before we ever get involved. So when we get involved, we're given all these reports, which we have to absorb and comply with. And that gives us the guide for our design for the building.
Thank you.
So I agree. I understand that things would be different where you're from, do it. And I've done a bit of work in Asia as well, and in particular in the Philippines, they use American standards, which are different to ours. And I've worked with British standards, which are different to ours. So you've got to get used to the local codes. And but I mean, we're all over the world. We all have the same idea that we want to provide a safe environment for people to live in or work in. But the way we go about it in different places can vary. So we just need to know what the local standards are.
That's right. Yeah. Thank you.
Okay. Do you want to, I know you're busy. Do you want to keep this to half an hour?
Yes, please.
Okay, well, let's just finish off with talking about the type of projects that we get involved in. So we've got commercial offices, which could be high and low rise. And you're working, or doers working on that sort of thing at the moment, commercial office space. Hospitals and healthcare, laboratories, and pharmaceutical. Those three there are very technically challenging, and you'll get involved in some of those at some point, and they're really interesting. There's all sorts of things in there, not just air conditioning and ventilation. I mean, that's what you're doing, but it's a lot more complicated. University buildings as well sometimes can be quite technical with scientific laboratories and so on. Industrial developments, shopping centres is quite common. Schools, you're doing some schools as well. Residential, aged care developments are similar to residential developments. Mixed use, where you have commercial and residential mixed together, and maybe other things as well. Hotels, casinos and clubs, auditoriums, theatres and public halls, they have pretty special requirements in the NCC. So if you come across those types of projects, you need to have a good look at the NCC and understand what we need to do. Art galleries and museums are very interesting. They have very tight temperature control, temperature and humidity. I did a museum in Sydney just before I retired, and it was really interesting. So if you get one of those, that's a challenge as well. Warehouses and distribution centres, data centres, Data centers are, there's a lot of those being built, and they're very technical as well. So there's lots of good projects out there, and you'll be involved in all of these things at some point in your career. There's probably more too that I haven't thought of yet, but that's quite a list to think about. So if you want to stop there, we'll make another time and just continue on. And if you've got any questions, just give me a call anytime.
Yeah. Where can we find this document?
The video. Oh, this one. Oh, I sent this to you by email last week.
Oh, you did. Oh, all right. Okay.
Yeah.
So that's the one. All right.
I haven't put it in the file yet because it's really a draft at the moment, and I'm still working on it with Phil.
Mhm.
So, but he
I'd
wanted
like
to
take a look at the final draft.
Yeah. I sent you a PDF.
Yes, that would be amazing.
Last week
Thank
sometime.
you.
Yeah, have a read through, and if you've got any questions, just give me a call. But Phil just wanted me to work through this with you, just to look at the overall context of what we do, who we are, and what we do.
That's amazing. It's
Okay.
always important to know where we are and
Yeah.
who we are. Thank you so much.
Okay. Oh, no, thanks.
Thanks.
I'll see you soon.
Thank you.
Bye-bye.
Okay.
See you.
Bye.